Good morning friends. Today I am going to explain the one of the important topic from current electricity, that is nothing but a Wheatstone bridge, and this is the one of the application of Kirchhoff's law. So in this Wheatstone bridge there are four resistances are there, A, B, C, D, which are connected in a closed circuit K, L, M, N. Here four conductors of resistances A, B, C, D are connected to form a closed circuit K, L, M, N, and a galvanometer of resistance G is connected between one pair of opposite junctions L and N, and between the other pair K and M. Here in between G galvanometer G of resistance G is connected in between. A battery of EMF is connected. So what is EMF? EMF is nothing but it's a electromotive force which derives the electron, and this is connected in between the 2 points, that is K and M. This particular network is called a Wheatstone bridge. Now here the current I is from the E branches uh, out into I1 and I2 at K. So at point K, the current I is divided into two currents, that is here I1 one side and I2 another side. Now I1 divides into I3 and IG. Again this I1 is divides at point L as I3 and IG at point L. Now I2 and IG meets at N. Now again I2 and IG meets at point N. Okay, and flow as I4 through D. So when IG and I2 meets at point N and flows as I4 through resistance D and meet at point M. Now I3 and I4 both are combined form I and flows back to the E. Okay, so this is the arrangement of the Wheatstone bridge. Now we are going to apply the Kirchhoff's first law for the junction L. So first we are going to apply the first junction L. So we all of you know that the current flows towards the junction is taken as the positive, and when your current is flows away from the junction is taken as the negative. So here I1 is moves towards the junction L at point L. So that's why it is positive. Next I3 is moving away from this point L. So minus I3. Now IG is also moving away from this point. So that is minus IG is equal to the 0. Now take this is equation number 1. Now for the junction N, now we are going to consider the second junction. So what will be the current here? That is I2 is moving towards the point N. So that is I2 is positive, and IG is also moves towards the point N. So that is taken as plus IG. Next I4 is moving away from the junction point N. So that's why I4 is minus. So it is equal to the 0, and let us take this is equation number 2. If the resistance says A, B, C, D are adjusted such that the current through galvanometer is 0. So our aim is we should have to make the galvanometer current readings will be 0. So when it becomes 0, it means the bridge is balanced. So when IG is equal to the 0, then the bridge is said to be a balanced. At the balanced point, I1 is minus I3 is equal to the 0. So from the first equation we can write IG is equal to the 0 means I1 minus I3 is equal to the 0. So we can write I1 is equal to I3. Let us take this is equation number 3. Now come to the second point, second equation. When IG is becomes equal to the 0, then I2 minus I4 is equal to the 0. So I2 minus I4 is equal to the 0, or we can write I2 is equal to I4. Let us take this is equation number 4. Now applying the Kirchhoff's second law for the loop, that is KLNK. First we are going to apply the first loop K, L, N and K. So again we have to remember the current is move away from the point is taken as the move away from this point is taken as a positive, and move comes towards the junction is taken as a negative. So I1A plus IgG. Say I1A plus IgG minus I2C here. So we know that the Kirchhoff's second law is related to the voltages. So voltage is nothing but it's a product of current and resistance. Here the current is I1A, the resistance is A, and plus next Ig, the resistance of the galvanometer is taken as G. So Igg minus I2C. Okay, so this is again this is move away from the junction, so that is minus I2C is equal to the 0. And for the closed mesh LMNL, here the second one is LMN and again L. For this, if you apply the Kirchhoff's second law, or voltage second law is related to the voltage, so we will get I3B, here I3B minus I4D, so I4D and minus IgG, and is equal to the 0. So when the Wheatstone bridge is balanced, means when Ig is equal to the 0. So when Ig is equal to the 0, so this we have to substitute the value of Ig is equal to 0 in these equations. We will get here I1A is equal to I2C, and let us take this is equation number 5. And next similarly, if you apply the Ig is equal to the 0 in the next second equation, sorry, this is fourth equation, then we will get I3B is equal to I4D. And let us take this is equation number 6. Now we are going to divide the equation number 5 by equation number 6. Then I1A by I3B is equal to I2C by I4D. So but we know that already in this we have given I1 is equal to I3. So already we got here I1 is equal to I3 and I2 is equal to the I4. So that's why both when you substitute the value of I1 is equal to I3, then I1 get cancelled. We will get A by B is equal to C by D. So this is the principle of Wheatstone bridge. And in this formula, if two resistances are known, the other two can be compared, or if we know the three resistances are known values, then we can find out the fourth resistance value. Now, balancing condition of Wheatstone bridge. So already I told you what is the balancing condition when the galvanometer shows the G is equal to the 0. So at that time A by B is equal to the C by D. So if A, B, C and D are the resistance in the four respective arms, then the balancing condition for the Wheatstone bridge is given by A by B is equal to C by D. Here few applications are there. Applications of Wheatstone bridge. When a little strains are developed in hard metals, can be measured very accurately by Wheatstone bridge using a strain gauge. Next another one is second one is the unknown resistance C and D can be compared from this balancing point A and B is equal to C by D. So if you don't know the what is the value of the resistances, unknown values, we can find out the value of the resistances also. If the value of one of the resistance D is known, then we can measure the value of the other unknown resistance C. Thank you. For more videos, subscribe my channel Physics.